Hello everyone, welcome to Gchem classes. So today we are going to discuss the chemical kinetics part 2, where we have already discussed order of reaction, half-life, rate constant, and then we are going to discuss it today, the consecutive reaction or sequential reaction. We are going to discuss it. We'll see whether K1 is greater than K2 is greater than, or K3, which one is greater than. And then simple reactions we'll see how to calculate the equilibrium constant, and then enzyme turnover number, turnover frequency, what all these things we are just going to discuss in today's lecture. Okay, so by yesterday's lecture and today's lecture, it is combinedly it is like a full package of a chemical kinetics where everything you will get it, and you can solve it in your upcoming examination, correct? So just we'll start it today, the consecutive reaction. Or we can say it sequential. Okay, sequential reactions. Suppose one reaction we have, I'll just put the graph. Before putting graph, I'll just write it down the reaction. So it will be, suppose we have A, from A we are getting product B. Okay, so this will be K1, correct? And then from B we are getting the product P, and this rate constant is K2, because both it can't be same, right? So for rate constant K1 and K2, so which one is greater than, which one is the rate determining step, everything we are going to learn it by this equation. Okay, the consecutive reactions or sequential reaction, whatever is there, these are the sequential reaction, right? So A to B, and then B is a intermediate. With the B we are getting the product P, then we will discuss it. So one graph is, this is A. Okay, concentration in y-axis, and x-axis it is time. So like as time is passing, what is happening, our concentration, initial concentration is decreasing, that is for sure, because with this only we are getting intermediate and then product we are getting. So next step, what will happen, formation of B. So how the formation of B is taking place, let's see. So this will be graph for B. So initially what is happening, as the concentration is decreasing, for initial concentration is decreasing, the B, concentration of B is getting formed, right? First this will get formed. So initially it is very fast, and then when it is reached to the peak, what is happening, the next, the B concentration is decreasing, right? Why it is decreasing? Because we have another concentration which we call P. So that product is getting formed, right? So this is for product peak. So now if they will ask the question, before that we'll just write it down, what all points are there in this. Just first step is concentration. We can see it, the concentration of A is decreasing exponentially. Okay, so concentration of A, I'll just use this symbol, decreasing exponentially. Okay, now for the concentration of B, what is happening? For concentration of B, first it is increasing, okay, and then again it is decreasing, correct? Concentration of B increases up to maximum, we can write it up to maximum, then it is decreasing. Okay, then it is decreasing. Now for the concentration of product, okay, what is happening? It is also increasing. Concentration of product is also increasing. So these are the data we are getting it from here. Now in examination, this statement type question also they may ask, and they can ask you whether K1 is greater than K2, or K2 is greater than K1, or K1 is equal to K2, they can ask it. So in this particular graph, what we are going to learn it here, K2 will be faster than K1. So it means your K1 is a rate determining step. This is the slowest step. Okay, and this will be fastest step. So rate determining step is your K1. This is rate determining step. Okay. So here K2 is faster than K1. You just see this B is formed till this much and then again it is dipping down, right? And then product P formation is exponentially fast and it is like you got it, the product, right? So here if you are comparing the rate constant K1 and K2, you are getting this rate constant is slower, okay, and this one will be faster, correct? This graph will be faster. So whenever they'll ask in question their graph, like in board I can't make it the completely like the inch and inch I can make it for graph, right? But in book or in question paper, whatever they'll ask, to comparing the graphs, okay, one or two graphs they'll ask you. Based on that they will ask which rate constant is faster and which rate constant is slower. Okay, we have many questions from PYQs, we'll solve it, don't worry. Okay, so this is one condition. One more graph I'll draw it here itself, so it will be easy for you to find out which rate constant is faster and which one is slower. Okay, one more graph I'm just drawing it here only, and then we will discuss it, which one is slower and which one is faster. So this will be time. So one more graph I'm just putting it here itself. So this is temperature, time, and this is concentration, correct? So how this graph will work, this will be like this is B, okay, and then this concentration will also come down. This is A, okay, and one more will be there. This will be your P, correct? This will be your P. Now in this graph you see it, so A to B and B to P. So this is K1, this is K2. So which one is the more, like K1, rate constant of K1 is more, like, or K2 is more, but like which one is faster? If it is more, okay, if this rate constant is more, this will be faster. If this rate constant is more, then this will be faster. Okay, K1 or K2, you just see it. So in K1 we are formation of B, right? We are just forming B, correct? And then for B to P it will be K2. So here it will be K1 is faster than K2. Right? How? See? Exponentially growth, right? So this will be faster than your this downgrade, right? It is slowly decreasing, right? So K2 will be slowest and K1 is faster. So here the rate determining step is this one, okay? Rate RDS, rate determining step is K2 from B to P, right? This will be faster, K1 will be faster. So likewise graph they will ask, see here the this graph length and this graph length, okay? So easily you can identify, okay, this type of question they are asking many nowadays. So we'll see how this will work. So now the calculation part we will do it, the steady state approximation, okay, and then we will take it to the questions, because I am very much interested to take the questions and solving those questions, right? I think you also waiting for the questions itself, not theory. You also don't like theories, right? But you should go through with the theory, then only you can solve the questions, right? So reaction mechanism, okay? Simple reaction mechanism. So in this, suppose we have A to B and then B to product P is formation. This is K1, this is K2. This is a simple type of reaction. Here we know that K1 is a rate determining step, RDS. Just suppose that we are not putting any graph. If graph is there, you just take the second graph, okay? So K1 is a rate determining step. Now you have to calculate how much B has formed and how much P has formed. What is the formation of product of P, or what is the formation of product of B? So how you are going to calculate that, we are going to discuss it, okay? So here first we will calculate this one. How much it will come? It will be like K1 by K2. I'm not taking up the concentrations, okay? Just I'm calculating the values like rate based on the rate constant, how you will get the product concentration, right? So this equation will help you out to find out the product, okay, product formation rate, correct? And if you want to see the product like final product, if you want to see for final product, it will be like dP but a dP equal, it will be K1 and completely depend on your initial concentration A, right? So these two equations will help you out for this type of reactions. So there is no equilibrium here, right? Directly from A to B we are getting B, and from B we are getting directly product P, right? So if this kind of reactions are there in questions, you have to follow. If they are asking what is the intermediate concentration, what is the formation rate for intermediate, it will be like this value you have to put it. For product, this value you have to put it and you have to calculate it, correct? So this is the type 1 reactions. So type 2 also we will discuss it. What is the type 2? Let's see the type 2. So type 2 means from A to B you are getting, I'll use this arrow, that is the K1, and from B again you are getting product A. So this, they are maintaining the equilibrium, correct? And then in the next step, whatever the B has formed, from this you are getting the product. So this is K2. So how you are going to calculate for this type of reaction, okay? Here dB dt equal to K equilibrium, we call it, right? K equilibrium. What is K equilibrium? It will be K1 divided by K minus 1. This is the K equilibrium, correct? Based on that you will calculate it. If they are asking for product, how you are going to calculate? It will be like K2 and then K equilibrium. So how? So K2 into K equilibrium is K1 but a K reverse, correct? K reverse. So with these equations you will calculate this type. This is type 2 reactions, right? Type 1 is directly A is forming B, and from B it is product we are getting. But in this reactions, from A to B we are forming, but B, if we are keeping as a B again it is forming A, right? So this is a maintaining a equilibrium. So that's why this equilibrium based. Like in equilibrium you have to calculate the product B, and from B again we are getting P. So for that we have to take it both the like rate constant K2 as well as K equivalent, right? So K equivalent already we have these values, we can put it and we can get the product number whatever it is there, okay? So these are the things. Now we'll start solving the questions. Whatever the new concept, it will come in questions. We will discuss it there itself, correct? So let me take up the questions. Here is your first question, you can see in the screen. For the reaction, one reaction they have given, you see the reactions in screen. And then the rate expression, they have written that the rate expression is very much important in this question. This has asked in 2022, okay, and question number 9, correct? Question number 9, it is very much easy, they have asked. So K they have given H2 PO2 minus and then OH minus. Here with respect to H2PO2 minus it is first order, with respect to OH minus it is second order. Overall it is a third order reaction. Now what they are changing, if the concentration of H2PO2 minus is doubled, so this concentration what they are doing 2 times, means they are just doing doubles for this concentration, and we know that this is a first order reaction, right? So whatever is happened in the reaction to the product side, it will be doubled. If it is 2 times, it will be doubled. If they are changing this concentration, if they says that this one, that the OH minus concentration we are increasing for 2 times, like we are making this double, then your reaction product will be 4 times, right? 4 times. If this one they are doubling, then your entire reaction like product will be doubled. So you see the option C will be your correct answer for this type of reactions, correct? Because this is first with respect to this substrate it is first order, with respect to this substrate it is second order. So if first order they are doubling, your product will be doubled. If second order they are doubling, your product will be 4 times, correct? So likewise this answer is doubled. So 2022 only one question they have asked. Now we directly go to the 2021. Okay, I'll drop the board. So now question from 2021. Okay, question number 28. Question number is 28 and they have asked in 2021. It is like they have, you can see the questions in screen. Half-life of a chemical reaction varies with the initial concentration of reactant as given below. Okay, initial concentration they have given. Okay, initial concentration, one is 5 into 10 to the power minus 2, one is 4 into 10 to the power minus 2, all will be mole per liter, right? One is 3 into 10 to the power minus 2. Now they have given T half. See, this is very easy question. With a second you will tell the order of reaction, okay? 450 and this is 600 second, right? Everything is second, this is mole per liter. So this type of question if they are asking and they are asking the order of a reaction is very much easy. You just see it, when the initial concentration is 5, this 10 to the power minus 2 is common for all, right? We know that this initial concentration is more, this one is lesser and this one is again lesser. Now what is happening, when the concentration is more, your initial concentration, like the time required is less, concentration you are decreasing, initial concentration you are decreasing, time requirement is more, and then again initial concentration is further you are decreasing, your time requirement is more. So we have already, when n equal to 0, T half is directly proportional to your concentration. Whether the concentration is increasing and your time is increasing, no. Here what is happening, inversely proportional, time and concentration. Concentration is more, time requirement is less. Concentration is less, time requirement is more. Concentration is further less, time requirement is further more. So that's why I told you that table you just, like yesterday I have discussed, right? That table is very much important. Now n equal to 1, everything I'll write it 1 second here. So T half is directly proportional. This is not proportional, this is constant, right? It is not depend on initial concentration. Now if n equal to 2, second order reaction, T half is inversely proportional to concentration. N equal to 3, T half is inversely proportional but exponential square, correct? Now it is not square, right? It is not that much decreasing, that if it is more concentration 360 and if it is the lesser concentration we are taking, it will be in 1000. If it is in 1000, then only we'll say we'll go for third order reaction. For this type of reaction you just see the difference is not much, so we can easily say this is the second order reaction kinetics. Okay, second order reaction kinetics. So your questions, option A is 0, B 1, C. So option C will be your correct answer, correct? So that's why I'm telling, just do practice all these things, okay? The order of reactions. Now next question we will take it from the same year, 2021. Next question will be question number 30. This is a direct question, no need to solve it. They are asking from X, this reaction type is like rate of reaction is Kx, then it is forming Y, then rate of reaction is Ky and forming Z, right? Now they are telling that initial concentration is C0, okay? Is the initial concentration of X, the concentration of X, Y and Z at time T. So this will be time equal to 0, then it is C0 and these are the 0. At time equal to T, then this concentration will be Cx, like the remaining it is, like it is remains Cx, this will be Cy and this will be Cz, okay? The expression for the concentration of Y at time T, see, at time T equal to T, what will be the concentration of this? That you have to put it in the formula. Kx minus Ky, where it is Kx minus Ky. First option, B and D, it won't be because they have taken initial concentration, like they have framed it with Cx. It won't be Cx, it will be Kx C0, Kx C0. Okay, so A and C, in between A and C, which answer will be correct? The first part is, both is having correct. Both is having this one, Kx and C0 divided by Ky minus Kx. Both are having same. The second part, it should be e to the power minus Kxt and then it will be minus e to the power Kyt. Which one is having? Option A. So option A will be correct. Correct. So option A will be your correct option. So now we'll go for the next question. If you have any doubt how it happened, it is direct formula, right? First you take for this one, okay, whatever it said. then you just do minus with this one, you will get this product. Okay, this is direct formula they have asked from direct formula based question. And then next question is question number 59. I think numerical aptitude type question. Question number 59. Okay, let's see what is question number 59. With the same year, okay, 2021. Question number 59. What is that? For a reaction Q plus R, okay, K1 and then C, K inverse. This is the equilibrium, and then X they are forming, then K2 and the product P they are getting. So they have given the value for K1, they have given 2.5 into 10 to the power 5 liter per mole per second. With this unit you will come to know this is a second order reaction, correct? Now K inverse is equal to 1.0 into 10 to the power 4 per second. With this one is, again, this one is first order reaction, correct? And then, sorry, this one is second order reaction, this rate constant K. So from here to here it is second order reaction, from here to here it is per second, no? So first order reaction, that you keep it in mind. Next time maybe they will ask that order of reaction for this, order of reaction for the K inverse, they can ask that based on the unit you have to find it out. This is second order reaction and this K inverse is first order reaction. Now they will give this K2 value also. K2 value is 10 to the power, nothing, 10 per second. So this is also first order reaction, correct? Correct. So now what we have to calculate, under steady state approximation, the rate constant for the overall reaction in, okay, rate constant for overall reaction, okay, overall reactions rate constant. So I'll write KOV, okay, how much they are telling that it should be in unit liter per mole per second, means overall reaction is second order reaction they are saying, correct? Now we have to find it out, okay, liter per mole per second and steady state approximation, right? And overall reactions we have to find. So overall for this product we have already known that it will be K1 divided by K inverse, correct? That is means K equilibrium. For product, how much it will come? How much it will come? It will be like your K2 into K equilibrium, correct? K equilibrium, and we know that K2 into K equilibrium is K1 divided by K inverse, correct? So how much it is coming? Let's see K2, how much K2's value? 2.5 into 10 to the power, we will frame it, it is 10 to the power 4, right? So what we will do it? 25 into 10 to the power 4 into how much K1? K1 is 10 divided by what is K in this K inverse? K inverse is 1.0 into 10 to the power 4, right? So 10 to the power 4, 10 to the power 4 get cancelled. This is only 1. So 10 into 25, it will be 250. Okay, so 250 mole per liter. 1 second, unit should be liter per mole, right? Overall reactions is second order reaction, right? Mole inverse per second. So 250 liter mole inverse per second. So this is numerical aptitude type question. So rounded up to the nearest integer. The answer will be 250. Okay. So for question number 59, its answer will be 250. So for next year we will take it the year 2020. Okay, 2020. Let's see how many questions we have asked in 2020. Question number 31. Okay, 2020 question number 31 they have asked. For the reaction shown in scheme 1, the concentration profile of different species provided. Okay, they have given R, S, then product P. Two different path is there, Q and then product P. This is K1, this is K2, this is K3, this is K4, and based on this graph we have to find it out. Okay, the graph is like, we try to draw it. Okay, this is time, this is concentration, and then this is the reactant, and this is the product. This is reactant R, and this will be your S, this one, and this will be your Q. Okay, now what you have to find it out, because 4 options they have given, you see the options. The first is K2 is greater than K1, whereas C, K2 is greater than K1. So R2S is this, or R2Q is this. See, this is the like more faster, right, concentration with the time. So this rate will be more. So it's true, K2 is greater than K1. Okay, option A will be correct. K2 is greater than K1. So option B is K3 greater than K1. Let's see, K3 is greater than K1. K3 is greater than K1. So R2S, this one, and S2P, this one. So see, in the question you will see, if you are seeing, this will be like taking slowly, and this will be like little bit, this sharpness is there. Yes, this sharpness is there. So this rate is more compared to this one. So now the K3 will be option B. Your K3 is greater than K1. This is also true. And option C, K2 is greater than K1. Let's see, K2 is greater than K1. Already we have to. K2 is greater than K4. We have. This is option C. Actually, this is option A. So K2 is greater than K4. Let's see, K2 is greater than K4. So R2Q and Q2P. So Q2P. So this is more, and this is taking more, like this is taking less time, and this is taking more time. So this product formation is taking more time. So it's true that K2 is, that the rate constant of K2 is greater than K4. So likewise, so A, B and C, because K1 is not equal to, K1 is equal to K2 can't be possible. This is not possible, because K1 and K2 you just see, this is K1 R2S, and this is K2 R2Q. So these two are not similar, right? So D option will be not possible. So A, B and C will be true for this particular questions, correct? Now the next question we'll see for 2020, it is not there. 2020 there is no next question. We'll see the 2019. 2019 we'll see the questions, correct? So in 2019 questions is question number 1. In 2019 question number 1 they have asked, first question only rate constant they have asked. A plus B is giving your product P. The unit of the rate constant is mole per liter per second, right? So mole per liter per second. So this will be your 0th order. Okay, they are asking the same question. See, the option A will be correct order. So this is 0th order reaction. Okay, this is very much easy questions they have asked. Now the next question is question number 15, correct? Question number 15. They have given the half-life of a chemical. Question number 15, I'll just see what is that. Half-life of a chemical reaction A2 product. Okay, A2 product it is forming for initial reactant concentration of 0.1 mole per liter and 0.4 mole per liter. Okay, these two concentration we have, and they are telling that the time, this requires time is 200 seconds. If we are taking this concentration 0.4, if we are taking, the time required is 50 seconds. Okay, again this is inversely proportional, right? So T half is inversely proportional to concentration. This is which order of reaction? This is nothing but second order of reaction. Okay, this is nothing but second order of reaction. We have already discussed in I think 2021 or 2022. The questions, similar questions they have asked, right? So this option will be second order reaction. So option C, correct? Option C will be correct. Now the question number 56, numerical aptitude type question. We'll see question number 56. So the question number 56, it is very nice question. We'll see. Let's make it question number 56. The turnover frequency of a catalytic reaction. They have given one equation, the turnover frequency of a catalytic reaction. Turnover frequency they have given. With 90% yield of a product is, so 90% yield of a product is how much it is coming. So first we have to calculate turnover number. So what is turnover number? The turnover number, we have number of moles of product. Okay, number of moles of product formed, divided by number of moles of enzyme or catalyst, we can say it's utilized. Okay, number of moles of product formed and number of moles of catalyst or enzyme is utilized. So you can see the number of moles of product form is only 90%. 90% means 0.9, because 1 mole reactant they have taken and product form is 0.9. So 0.9, and the catalyst concentration is 0.01. So we can directly write it down, because 90%, 1 moles 90% will be 0.9, right? Divided by, we have 0.01. So into 10. So it will be 90. Correct. Turnover number is 90. So turnover frequency, how much it is coming? The turnover number divided by time. So turnover number is 90 divided by, we have 5 hours. So how much it is coming? 51408. So 18 hours. Okay. So your option will be, like we don't have option, per hour it is given. So 18. Answer will be 18. Okay. So is there any other questions are there? You can ask me directly. I have completed everything. So thank you very much.